We're on to the last part now. We looked at areas last time. Let's look at the issue of negative areas. So if I sketch the curve, x cubed minus 3x squared plus 2x, remember this is just a different way of writing it. Can we calculate this integrated between 2 and 0? And what is interesting about this? Well, if you just chuck all of this into your calculator, you'll get an answer of 0. Okay, so it says it's 0, but if you draw it, clearly if you added the area of all these rectangles together, because that's what integration is, it's adding the area of all these rectangles together, you shouldn't get 0. The answer is definitely not 0. We don't know exactly what it is, but there's no way that it's 0. So how are we going to handle this? Well, this is what we're going to talk about in a second, and you might have an idea for it already. This notation here on the side, by the way, this is just telling you that integration is when f of x is like the y height, d of x means the width of the rectangles, and integration just means adding together lots and lots of rectangles that are infinitely thin. That's what integration is. So don't worry about the notation here. Anyway, how do we handle negative areas? Well, splitting it up. I bet quite a few of you would have been thinking that already. And then because area, well, you don't really have negative areas. An area is just an area. So we're going to handle them all as positive. So if we get an area of minus 10, let's just call it 10. Well, we're going to find this one here. So this should be some positive value. So let's pretend. In fact, there's no need to pretend. We can just calculate it ourselves. If I integrate this one between 1 and 0, yeah, if I integrate it between 1 and 0, so I handle this as like part 1 and part 2. Well, if I do part 1, and in the interest of time, I'm going to do this on my calculator. So if I integrate x multiplied by x minus 1 multiplied by x minus 2, if I integrate that whole thing between 1 and 0, I haven't done it correctly. Why not? X multiplied by x minus 1 multiplied by x minus 2. Let me just quickly see if I can fix that. Okay, well, let's just pretend. I'm going to pretend I get an answer of 10. So if I got an answer of 10 there, and then when I did this one here, I got an answer of minus 10, what would I do? Well, I would just take the absolute value, a bit like magnitude in mechanics, and I would say that the area is 20. Okay, a bit neater. Do we have a neater example? Yes. So it's not 20, it's actually a quarter. And then you might sort of see that this has some rotational symmetry. So the other part becomes minus a quarter. So we take the absolute value, we would say that the total area of both blue parts is 1/2. Pause the video then and have a go at this one here. And don't forget to look at the hints to help you out. So I'm assuming you've done that now. Inspecting to find the roots, you should see that 0 clearly, minus 4 and 2 are the points of value. These will be used as our limits. So we will integrate between 0 and minus 4 on the left-hand side, and then we will integrate, if we can find it, between 2 and 0 on the right-hand side. Okay. We should get 42 and 2/3 and 6 and 2/3. You'll probably get a positive here and a negative based on the way that you've done it. Finally, then we need to add them together. So we want to get an answer of 49.3 or 148/3. It's important here to see that it is not negative because your area needs to be positive. Okay, and the very last step, what can we do? Well, we can find more complex areas such as this one here. So the technique is you need to look at that blue part there and think, how can we find that? Remember, if you want to find the area under a curve, that's integration. Okay, it can only do under a curve. It can't do over a curve. It's only under. So how could we find this area? Well, we could integrate as we normally would to find that part there, and then we could take away the triangle. So better to start with more and then take away something. For example here, so this is the same question. We need to find these limits. So the limits, well, that's 0, as you can see. The limit here is 3, okay? And when you're integrating with limits, it will only be looking between this section, yeah? It's not looking at any of this here. So we have the area under the curve in this section, and then take away the triangle in this section. The triangle, well, this is just 3. The value up here, so you can substitute x equals 3 in, and apparently you will get 3 again. So you just do base times height divided by 2. So we do the area under the curve, which is the large part, and then we subtract the triangle, and we should get 9 over 2. Slightly more difficult, this one. Remember, integrating gives you the area under a curve, or the area under something, under a straight line. So how could you do this? Well, the easiest way to do it this time, again, is start with too much. Why don't we start with this one here, the triangle enclosed here, and then subtract the area under the curve for this part here. So start with OBC and subtract the curve under AC. So the x value at A, well, how could we find this one here? Inspecting the quadratic, it says that it's going to be 3, isn't it? Okay. What about the b value? Well, you'd need to solve these simultaneously to get the b value. So 2x equals x multiplied by x minus 3. It's probably easiest if we do 0 equals x squared minus 3x, and then bring the minus 2x over as well. So it will be x squared minus 5x, which shows you that it's x and x minus 5. So what we want to be doing then is the value, x value at A, well, let's just say that this is 3. The x value at B, well, this is 5. So integrating, we want to integrate this curve. We want to integrate the x multiplied by x minus 3 curve with respect to x between 5 and 3. Find this and take it away from the triangle that would encompass this, that would be OBC. So let's look at a neater version. So 5 and 3. So we found 5 and 3. We find the area of the triangle. So this is 5. It's 10 high. You can just substitute it in here to find the height. So 5 times 10 times a half is the triangle. When you integrate this thing, you get 26 over 2/3. So when you subtract, you will be left with this. There are other ways to do it, but this is sort of the recommended approach to answering this kind of question. Pause the video then and have a go one last time at this. My advice is to remember that you are only working between here and here. So find more to start with and then subtract away until you are only left with the shaded section. And if we have done this, A and B we find by simultaneous equations. We can find those coordinates there. Why is that important? Because 2 and 9 will be your limits for integration. So you're going to integrate, I'm going to say integrate the curve with respect to x, and then you're going to take away the area of a trapezium. So you're going to take away that shaded in region there. And you can use the coordinates again to help you do this. So that is 8, that is 1. So there's your A and B, and your height is going to be 7. So it should leave you with an answer of 57 and a sixth, or 343 over 6. Okay, and that takes us to the end of integration for now.